Hello everyone, welcome to the NPTEL online certification course on fundamentals of food process engineering. We are in the last chapter of our course, that is non-thermal preservation for food, and in that we have already discussed few techniques in non-thermal processing, such as high pressure processing we have discussed, pulse electric field technology, and pulse light also we have discussed. We need to discuss now irradiation, then ozone and coal plasma technology, and finally the Hurdle technology. So, in today's class we will discuss the food irradiation. So, food irradiation is one of the very important non-thermal processing, and this has been becoming very popular method day by day because of its highly effective way for inactivating the microorganism. So, we will see that irradiation is the process by which an object is exposed to radiation. Irradiation is the process by which an object is exposed to radiation. So, you have to have the clarity here. Radiation means the intensity of the light that comes, intensity of the radiation that comes from any light source, but irradiation is the process by which the object is exposed to radiation, right. So, the exposure can originate from various sources like alpha particle, beta particle, high energy electron, gamma rays, X-rays, etc. And what happened that when these rays, X-ray, gamma ray, and these are capability of the ionizing the material, okay, ionizing the gas. So, when they ionize, that means they remove the electron from the atom, okay. So, then what happened that they produce the charged ions, okay. So, this the charged ion they form, and that charged ion, and eventually they form the free radicals, because this charged ion can stay for a very short period of time, okay. So, eventually they produce the free radical. So, that means the effect of this free radical and the charged ion, they will destroy the microorganisms, okay. So, this is basically how they work. So, gamma ray, X-ray and beta particle. So, these are having very small wavelength. So, therefore, these are having very high penetration capability as well. And for food system, there are certain specified source which are used for this kind of irradiation treatment, such as cobalt 60, then cesium 137, okay, machine generated beta or X-ray. So, when these rays fall on the any food surface, so they, because of their effect of ionizing radiation effect, they kill the bacteria. So, food irradiation is the process of exposing food stuff to ionizing radiation, as I mentioned, and this treatment is used to preserve the food, reduce the risk of foodborne illness, delay or sprouting or ripening. So, what happened that for food irradiation, as I mentioned, that these create the ionizing radiation, and because of creating those ionizing radiation, they form the charged ion and then eventually the free radical. So, the obvious question may be that this free radical will not damage the food itself, the constituents of food itself. So, the thing is their intensity of this radiation, that means how much a food can be irradiated, those are fixed. So, it has been designed in such a way, or it has been quantified in such a way, so that the microbes will be affected, but not the food will be destroyed or degraded, right. So, therefore, the mentioned limit of this irradiation we had to obey clearly. So, here food irradiation is the process of exposing food stuff to ionizing radiation, and this treatment is used to preserve food, reduce the risk of foodborne illness, delay or sprouting or ripening. So, these are the effects that it can cause. It can if it is not irradiated, sprouting may be there. If it is irradiated, then because of this irradiation, sprouting will not be there. Then so, after harvesting, if untreated fruit is there, there may be some microbial decay will be observed. If these are treated, there will be no such microbial decay. It will cause delay in the ripening as well. Okay. And this ionizing radiation that can penetrate through food to kill or prevent the reproduction of the microorganism, insect and pest. So, what will happen that when the gas become ionized, so the effect of the ionized radical, for example, this is O3 plus ion or hydroxyl ion or the H2O2, all such can generate this free radical and the ionizing effect on the microorganisms. So, we can see that food irradiation has several advantages. In industry, we can use it. So, this one process, that is food irradiation, can cause sprout inhibition. So, onion, potato, ginger, garlic that we need to store for longer days in warehouses, or for some industry preparation of the product. Before preparing the product, actually we need to store it. So, if these are irradiated, then no sprout formation will be there. So, it is very beneficial. Other thing is insect disinfestation. So, insect infestation is very common in cereal, pulses and dry fruits. So, we can't keep it for a longer time. The fungus attack, mold attack will be very frequent. So, therefore, irradiation treatment can be followed. Okay. So, thus we can save a large amount of the product. So, very cost effective thing. Then shelf life extension, since we can kill the microbes by this food irradiation method, we can store the product, even if it is the fleshy food, we can store it for a longer time. Then pathogen reduction on the spices, flesh food, etc. So, pathogen and even the some toxic substance reduction that can be done, fungal attack, everything can be prevented. So, quarantine of the fruit. So, even on the fruit surfaces also we can apply this food irradiation treatment to quarantine them. So, that means sprout inhibition, insect disinfestation, shelf life extension, pathogen reduction and quarantine, all this we can get by only one method, that is food irradiation. So, it is a non-thermal method and very effective method. Now, next is sources of radiation used in food irradiation. So, we have mentioned that gamma ray, X-ray and electron beam, these are the source from where we can get the source of radiation, and from that we use for example, the gamma ray, these are emitted from radioactive forms of the element cobalt. So, the radioactive form is cobalt 60 or of the element cesium, that is CS 137. So, these two are radioactive forms of this element and these can emit the gamma rays. So, gamma radiation is used routinely to sterilize the medical, dental and household products, and is also used for the treatment of cancer. So, these are commonly used, but which other than the food, this has already in practice. X-ray, these are produced by reflecting a high energy stream of electron of a target substance, usually one of the heavy metal, into food. Okay. So, X-ray are always widely used in medicine and industry to produce the images of internal structures. Electron beam or E beam, this is similar to X-ray and is a stream of high energy electron propelled from an electron accelerator into food. So, nowadays all three are used on food to have the irradiation effect. So, how the irradiation works? So, food is exposed to a carefully measured intense amount of ionizing radiation. So, this is very important, carefully measured intense amount of ionizing radiation, and this has been given by, there are authorities on specifically working on this standard measurement. I mean, how much the dose measurement, we can say that how much radiation dose can be given to a food material, so that its constituent will not be degraded because of the action of the ionizing radiation or free radical, but because the finally the radiolytic action will cause destruction to the constituent as well if it applies beyond a certain limit, and the food will lose its food value or nutritional value. So, that is why this is very important. Now, when food is irradiated, that is exposed to the radiative source of either X-ray or E-beam source or gamma ray, the radiation energy breaks the bonds in the DNA molecule of the microorganism. Okay. So, this breaks the bond in the DNA molecule of the microorganism, and thus the organism dies or become unable to reproduce. And frozen food takes larger radiation dose to kill the microbes, and the effectiveness of the process depends on the microorganism's sensitivity to irradiation. So, again it depends on, because the same dose may not be applicable for all the microorganisms. So, we have to decide the dose requirement for the different microorganism. So, this is how it is being done. The food, when entered into the chamber where they are they come in contact with the source of irradiation, and then while they exit, the microbes has been fully damaged. Similarly, the irradiation process we can apply on a large scale unit where the there is a loading area, and after loading of all the food material into crates or proper sections, those are inserted into the radiation room, and after radiation there is a, for example, here we are applying the cobalt 60 that generate the gamma rays, and then it has been unloaded. Okay. So, this is how the irradiation process, food are exposed to the irradiation process. So, dose and dose rate. Ionizing energy processes create enough of an absorbed dose to destroy microbes, and unit of absorbed dose in food, that is kilograms, and can be divided into 3 categories. Radicidation, that is low dose, that is less than 1 kilogram. This controls the insect in grain. So, doses as low as less than 1 kilogram, it can controls the insects in grain and fruit, inhibit the sprouting in tubers, delay the ripening of some fruits and vegetables, and reduce the problems of parasite in products of animal origin. For example, Trichinella spiralis in pork. So, we can see that a very low dose is required for all such activities, and these are very common to the common problems of the industry, and in some cases the small the small businessmen or the small farmers who need to store this product for some time. So, they have to they can apply these techniques. Okay. Then radorization, that is the medium dose 1 to 10 kilogram. So, this control Salmonella, Shigella, Campylobacter, Yersinia, Listeria, E. coli. So, basically we can see all the bacteria. To control them, we need this range, that is 1 to 10 kilogram, that can control the bacteria, that is Salmonella, Shigella, Campylobacter, Yersinia, Listeria, E. coli in meat, poultry and fish, and delays the mold growth on strawberry and other fruit. Okay. That means we can see that how mild radiation treatment to moderately high radiation treatment can cause the different functions in the preservation of the food. So, the next thing is little bit higher than this, radapodization, that is high dose greater than 10 kilogray that kill the microorganism and insect in spices, commercially sterilized food, destroying all microorganism of public health concern, okay, that is special diets for people with weakened immune system. So, for them this is to be used, and after that the irradiated food can be consumed. So, this is how we can define that what kind of dose or what is the dose rate required for different functions, whether it is preserving the produce for a longer time, whether it is decaying the ripening, whether it is killing the bacteria. Okay. So, this is how we apply the irradiation. Now, effects of irradiation on microorganism, which is an indirect effect. Okay. Later on we will come to the direct effect. So, indirect effect is that due to formation of the free radical during the radiolysis of the molecule. So, what happened that when the ionizing radiation or this X-ray, gamma ray, this fall on a food product. So, there are the particle of water, okay, water and oxygen, those particles are there. So, radiolysis of that water molecules will generate some free radicals. That free radical are highly reactive, they produce the hydroxyl ion, okay, or O3 plus ion, etc. So, they are highly reactive and they form eventually the stable products. Okay. So, that combine with one another, because they are highly reactive. So, they have to make other products to be a stable form. So, combine with one another or oxygen molecules and which works as oxidizing agents. Okay. So, this can damage, this oxidizing effect, this can damage the bacterial cell components. Okay. And then unstable free radicals react with the bacterial cell membrane, damage their structure and the bacteria dies. Okay. So, from this, as we have seen that water molecule, when they ionize, they will form hydroxyl ion OH minus and hydrogen ion H plus. Further, two of this will add and then form again more ions. So, this process will continue. Now, the direct effect is what? The ionizing radiation kills microbes by damaging the biomolecules of their cell. So, incoming photons hit the electrons in the atom of microbes or food molecules, and during the collision photons energy is transferred to the electron, changing the photons direction. Electron free to collide with the neighboring electrons, and this causes chemical bond breakage. So, it has seen that most of the organic bonds are getting affected by this and interrupts normal cell metabolism and cell division. Okay. So, directly the cell division is getting affected and indirectly the free radicals will form the destruction of the cell wall. So, these two will combiningly define the total effect of the irradiation on the microbes. Factors affecting the efficiency of radiation. So, the factors are temperature of food, then moisture content and presence of oxygen. So, temperature of the food, this will have some effect, because along with the ionizing effect, if the temperature of the food is also vary, so that will cause some additional effect in destruction. Moisture content, because if the moisture will be there, that will because of the ionizing radiation, that will form the free radical and hydroxyl ion or hydroperoxyl ions, etc. Those are detrimental to the microorganism. So, this will help. Also the presence of oxygen, because then it will cause the higher amount of oxygen will cause the oxygenation in higher amount, and that will kill the microorganism. So, oxidation, the amount of oxidation or the quantity of the oxidation will increase. So, the food molecules are made of water, lipid, protein, carbohydrate and vitamins. These are the constituents, main constituents. Radiation energy generates a degradative reaction with when it interact with food called as radiolysis. So, what happen, as the microorganisms are getting affected, when this radiation energy comes in contact with food, all these constituents also they are exposed to the effect of radiolysis. Okay. So, products of radiolysis is known as radiolytic product. Irradiation causes changes to food molecules, particularly at higher doses. That is why we have to be very cautious, so that we strictly follow the dose requirement. Sterilization levels causes nutrient loss and desirable nutrient loss and some effects also. Okay. So, this is about the irradiation, and we will stop here and we will move on to the next topic. Thank you.